Hi, welcome to Quantum Academy for Physics. I'm Swapna and I'm teaching you mathematical physics. In last class, we have learned about linear differential equations. The method which is helpful to solve differential equations of first order and first degree. And in linear equations, we have learned the standard form of the linear equation is dy by dx plus p of x into y equals to q of x, and the general solution for the linear differential equation is y into integrating factor, which is equal to integral of q of x into integrating factor dx. We have learned this in the last class, linear differential equations. And in today's class we will learn about Bernoullis equation. Bernoullis equation. Bernoullis equation is of the form of dy by dx plus p of x into y equals to q of x into y power n. This can be reducible to Leibniz linear equation. Leibniz linear equation is nothing but a linear equation. Linear equation is also said to be Leibniz linear equation. Bernoullis equation can also be reducible to Leibniz linear equation by taking n equals to 0. Substitute n equals to 0 in equation 1. dy by dx plus p of x into y equals to q of x. Y power 0 is nothing but 1. This is the form of linear equations. Okay. Now, how can we solve a Bernoullis equation? How to find a solution for Bernoullis equation? Divide by dividing
with
y power n, by dividing
With
y power n on both sides of equation 1. So y 1 by y power n dy by dx plus p of x into y by y power n equals to q of x. Y power n by y power n get cancelled. Now this can be written as y power minus n dy by dx plus p of x into y power, this is taken up for 1 by 1 y power 1 minus n. In denominator, y power n is taken to the numerator, which is equals to q of x. Now this is equation number 2. Please note down. Now put y power 1 minus n equals to z in equation 2. Y power 1 minus n is taken as z. Now differentiate this. Differentiate above equation with respect to x. dz by dx equals to 1 minus n into y power 1 minus n minus 1 dy by dx. dz by dx equals to 1 minus n dy by dx. Now from equation number 3, what is equation number 3? This one. Here we have in equation 3 we have y power minus n dy by dx. This is replaced by y power minus n dy by dx equals to 1 by 1 minus n dz by dx. Here, look at this equation. I have rewritten this equation. So now we have y power minus n dy by dx as 1 by 1 minus n dz by dx. I am replacing equation 2 in equation 2. This will become 1 by 1 minus n dz by dx plus p of x into, this is z. This is z into, I am not taking here, equals to q of x. Now rewrite this equation, dz by dx plus p of x into 1 minus n into, this is z, equals to q of x into 1 minus n. This is a Leibniz linear equation in z. This is Leibniz linear equation in z. Now compare this equation with linear equation. See, what is linear equation? dy by dx plus p of x equals to q of x. Here we have dz by dx plus p of x. In place of p of x we have p of x into 1 minus n equals to q of x. In place of q of x we have q of x into 1 minus n in Leibniz linear equation in z. Now we will solve few problems. Before solving, I want to explain one more point. Here in this equation, when we compare this equation with linear differential equation, p of x is replaced with p of x into 1 minus n and q of x is replaced with q of x into 1 minus n and z equals to y power 1 minus n. Remember these equations, these are very important equations to solve Bernoullis linear differential equation. Now I will explain a example problem of Bernoullis equation. Solve xy into 1 plus xy square into dy by dx equals to 1 equals to 1. Now solution is, rewrite the above equation, rewrite the given equation. Here dy by dx equals to 1 by xy into 1 plus xy square. Now dx by dy equals to xy into 1 plus xy square. I'm interchanging the numerators and denominator. I'm interchanging the numerator and the denominator to have a form of linear differential equation. Dx by dy, here xy multiplied with 1 minus xy equals to x square y cube. Here we have the equation in x. So here we have p of y and q of y, where p of y equals to minus y and q of y equals to y cube, n equals to 2 x power n. From this, replace p of y with 1 minus n into p of y, which is equals to 1 minus 2 is minus 1 into p of y is minus 1 into p of y is minus y, which is equals to plus 5. From this, replace q of y with 1 minus n into q of y, which is equals to minus y cube, and z equals to x power 1 minus n is 1 by x. Now using these three equations, I am solving a Bernoullis equation. Now the solution for Bernoullis equation is z into integrating factor equals to integration of q of x into integrating factor into dx. This is the solution for Bernoullis equation. See, if we have the differential equation in terms of dy by dx, the general solution will be z integrating factor equals to integral q of x integrating factor dx. This will be the solution for a Bernoullis equation. Here we have the differential equation in terms of dx by dy. So we have replaced here q of x with the q of y and dx with the dy. Now the general solution will be z into integrating factor equals to integral of q of y into integrating factor dy. We will solve for integrating factor. Integrating factor equals to e power integral p of y dy. Here p of y is, what is p of y here? Y, and q of y is minus y cube. P of y is y. Now substitute in this equation. Then integrating factor equals to e power integral y dy, which is equals to e power y square by 2. Now substitute this integrating factor in the general solution. Z into e power y square by 2 equals to integral of what is q of y minus y cube into e power y square by 2 dy plus c. Now I am taking y square by 2 as t. Now differentiate this one. 2y by 2 dy equals to dt. Now dy by y dy equals to dt. Here from this equation, integration of minus y square into y e power y square by 2 dy plus c. Y dy is dt. Integration of minus y square by 2. From here y square equals to 2t. So y square equals to 2t into e power y square by 2 is t, y into dy is dt plus c, which is equals to z into e power y square by 2. What is z? We have solved for z. This is 1 by x. E power y square by 2 by x equals to minus, now integrate this equation, we will have minus 2 into t e power t minus e power t plus c. See, I will explain this here. This is a UV form, integration of UV form. We can solve this by, I'm taking here t e power t. This is a shortcut actually to solve UV form of integration method. 2 is common. I'm taking t and e power t. Differentiate this t. Differentiate this t. Differentiation of t is 1. Differentiation of 1 is 0. And integrate this e power t. E power t integration is e power t. Now this is plus, this is minus. Here t into e power t minus 1 into e power t. See, look at this equation, minus 2 is common. T into e power t minus 1 into e power t plus c. This is the general solution for a given Bernoullis equation. You can further simplify this for required answer. I will give you one more example. dy by dx equals to y into tan x minus y square secant x. Now rewrite this equation as dy by dx minus y into tan x equals to y minus y into secant minus y secant square minus y square secant x. See, one thing you have to remember is the degree of y should be 1. So I have taken this term towards left, not this term. Okay. So from this equation, p of x is coefficient of y, which is minus tan x, and q of x is quotient of y power n is minus secant x, and n is 2, y power n is 2, and z is y power 1 minus n is 1 by y. So I'm rewriting p of x into 1 minus n is 2, 1 minus 2 is minus 1. So minus minus plus, we have tan x, and q of x into 1 minus n will be secant x. Now the general solution is z into integrating factor equals to integral of q of x into integrating factor into dx plus c. Now substitute q of x and integrating factor. So for integrating factor, we have e power integral p of x dx. E power integral p of x is tan x dx. Integration of tan x will be e power minus log of mod cos x. This will be equal to e power log of cos x whole inverse. This will be equal to 1 by cos x. Integrating factor is 1 by cos x. Now substitute here. What is z? Z is 1 by y. Integrating factor is 1 by cos x. 1 by y into cos x equals to integrating factor q of x is secant x into integrating factor is 1 by cos x dx plus c. This will be equals to, what is 1 by cos x? Secant x. This will be equals to integration of secant x into secant x will be secant square x dx plus c. What is integration of secant square x? Tan x plus c. Integration of secant square x is tan x plus c. Now we have 1 by y cos x equals to integration of secant x is secant square x is tan x. We have integrating factor, integration of constant c plus c, tan x plus c. Here 1 by cos x is secant x. 1 by y is y inverse equals to tan x plus c. This is the general solution for a given Bernoullis equation. Now we will learn one more method, that is exact differential equation. Exact differential equation. The differential equation of the form m of x comma y dx plus n of x comma y equals to 0 is said to be exact. The differential equation of the form m of x comma y dx plus n of x comma y dy equals to 0 is said to be exact. This is said to be exact when it satisfies, when it is this one, when it satisfies the necessary and sufficient condition of condition dou m by dou y equals to dou n by dou x. This is the necessary and sufficient condition for this equation to be exact differential equation. Now if dou m by dou y equals to dou n by dou x, then only the differential equation is said to be exact. Then the solution of this differential equation is integral of m dx, here where y is constant, plus integration of m dy, here terms not containing x equals to c. This is the general solution for a exact differential equation. Integral of m dx plus integral of n dy equals to c. Here the y terms are constant. Here we have to take the terms that which not contain x. Now we will solve a problem to understand. Now I am giving an example problem. Solve dy by dx plus y cos x plus sin y plus y by sin x plus x cos y plus x equals to 0. Now rewrite this equation in the form of m dx plus n dy equals to 0. dy by dx equals to minus y cos x plus sin y equals to y by sin x plus x cos y plus x. Now minus y cos x plus sin y plus y into dx cross multiplication equals to sin x plus x cos y plus x into dy. Now sin x plus x cos y plus x into dy plus y cos x plus sin y plus y into dx is equals to 0. Here we have dx, so this term will be m, this is n. Now we have m and n. Now we have to test for dou m by dou y equals to dou n by dou x. Dou m by dou y is equals to, differentiate with respect to y into cos x. Differentiation of y into cos x is cos x plus differentiation of sin y is cos x plus differentiation of y is with respect to y is 1. Sin y is cos y plus 1. Now check for n. Dou n by dou x equals to differentiation of sin x with respect to x is cos x plus differentiation of x into cos y with respect to x. Differentiation of x with respect to x will be 1, and we have left with cos y plus 1. So both these are equal. Dou m by dou y is equal to dou n by dou x. Then this equation is said to be exact differential equation. Now we can find the solution for the given equation. Now a solution for an exact equation is m dx integration of m dx plus integration of n dy equals to c. Here y is constant and here terms not containing x. We will solve for solution of the given exact differential equation. Now integration of what is m y cos x plus sin y plus y into dx plus integration of what is n sin x plus x cos y plus x into dy. Here y is constant, and here terms not containing x. Here the term we have x, here too we have x, here too we have x. So this this term will be equal to 0. Now integrate this one. Integration of y cos x. Here y is constant. I am taking constant outside. Integration of cos x will be sin x plus this is constant, y as y is constant. Integration of sin y dx will be x sin y plus integration of y dx will be x y, which is equals to c. Now this is the general solution for given exact differential equation. Now we will go for another method, homogeneous equations. Homogeneous equations. This is the fourth method, and this is the last method to solve first order first degree linear differential equations. Homogeneous equations are of the form of dy by dx equals to f of x comma y by pi of x comma y, where this f of x comma y and pi of x comma y are the homogeneous functions, and these are of the order of, and these are of the same degree in x and y. I will give one example for understanding this definition. X square x square minus y square dx minus x into y dy is equal to 0. Here x is having the degree 2 and the degree of y is 2. X into y degree is also 2. 1 plus 1 is 2. The complete equation have the degree 2. Okay, then this equation is said to be homogeneous equation. Now, how to solve this homogeneous equation? Step 1. We have to take first y equals to v of x. Y equals to v into x. Now differentiate this. Dy by dx with respect to x. Dy by dx equals to v uv method. Differentiation of uv is u into v. U into differentiation of v, that is v into differentiation of x with respect to x, dx by dx plus x into dv by dx. This will be equals to dy by dx equals to v plus x into dv by dx. First take y equals to v into x to solve a homogeneous equation. Now differentiate this x, this y equals to vx with respect to x. Now using variable separable method, next step is using variable separable method. Using variable separable method, the functions of v and x, we have to separate the functions of v of x. Using variable separable method, the functions of v and x are to be separated. Now third step is integrate the equation which we have in step 2. Now we will solve a problem. Solve x square minus y square dx minus xy dy equals to 0. Now rewrite this equation. X square minus y square dx is equals to xy dy. Now dy by dx equals to x square minus y square by x into y. This is equation number 1. Now step 1, take y is equals to vx, and differentiating this equation we have dy by dx equals to v plus x into dv by dx. Now substitute this equation in equation 1. In place of dy by dx, substitute this v plus x into dy by dx in equation 1. Dy by dx is v plus x into dv by dx equals to x square minus y square by x into y. Now step 2, using variable separable method. Separate the variables. Here y is vx. Substitute here first. V plus x into dv by dx equals to x square minus, what is y? V into x. Y square is v square x square by x into vx. V plus x into dv by dx equals to, taking common x square, and in denominator we have x square get cancelled. You have 1 minus v square by v. Now using variable separable method, we have to separate v and x terms. Now x dv by dx equals to, I am taking this towards right hand side, 1 minus v square by v minus v. This will be 1 minus v square minus v into v square by v. this is 1 minus 2v square by v, which is x equals x into dv by dx. Now now separate these x functions and v functions. Now I'm taking this complete term towards left hand side. This will become v by 1 minus 2v square into dv equals to, I'm taking x by dx towards right, this will become dx by x. Now step 3, integration. Integrate this above equation on both sides. Integration of v by 1 minus 2v square dv equals to integration of 1 by x dx. Now we know a formula. In our intermediate we have learned this. Integration of f dash of x by f of x dx is nothing but log of f of x. Log of f of x. Using this formula we will simplify this equation. So here f of x is this one. If we differentiate this one, we will have, if we differentiate 1 minus 2v square, we will have minus 4v. Here in numerator we have only v, so now multiply this equation with minus 4 by minus 4. Okay, now we have minus 1 by 4 integration of minus 4v by 1 minus 2v square dv equals to integration of 1 by x dx, which is equals to minus 1 by 4 into, this will be f of x. F of x is this one, log of f of x, log of 1 minus 2v square, which is equals to integration of 1 by x is log x plus c. This is the general solution for a given homogeneous equation. You can further simplify this for accurate answer. That's it for homogeneous equations. And please subscribe and comment in the comment box, and click on the bell icon for more notifications regarding Quantum Academy videos or lectures. Never ever forget to subscribe for my videos. Thank you.